This is day 1 of lesson 1.3. Today we're going to talk about midpoint. So the midpoint of a segment, all right, so we're going to fill in midpoint. Let's find our pen. The midpoint of a segment is a point that divides the segment into two congruent segments. So it's exactly in the middle, right? Middle point. So in this picture, B is the middle point between A and C. It's exactly in the middle, cuts it into two congruent segments. A point, line, ray, or segment that intersects a segment at its midpoint is said to bisect the segment and is called the segment bisector. Right? So in this picture, point B is the midpoint of segment AC, and line L, right, this is line L here, is a segment bisector of segment AC. So some important things to note. Let's just change the way this looks. There we go. So here, M is the midpoint of segment AB, which means that segment AM is congruent to segment MB, and the length of AM equals the length of MB. And in this diagram, line CD is a segment bisector of segment AB, which also means that segment AM and segment MB are congruent, and the length of AM is equal to the length of MB. So in this example, we have a skateboard, and segment VW bisects segment XY at point T. So it's a little hard to see, but we do have some congruence marks here because T bisected XY. We know from X to T is 39.9. We want to find the entire length of XY. So if T bisected, T was the midpoint, that means this side is also 39.9. So together, I could either do 39.9 plus 39.9 or 2 times 39.9, and we get a total length of 79.8 centimeters for XY. All right, you're going to try these two. Identify the segment bisector, either the point, line, ray, or segment that bisects the line, and then find the length of PQ. Pause it and then check your answers. All right, so for the first one, ray MN is the segment bisector, and if I add 1 7/8 plus 1 7/8, I converted them to improper fractions just to make my life a little easier. So we get 38, which is 3 3/4. And then for number 2, M is the segment bisector, point M. And then if I add 2 2/7 plus 2 2/7, I end up with 32/7 or 4 4/7. All right, so on our next problem, point M is the midpoint of segment AB. I want to find out how long AB is. So since it's the midpoint and we have our two congruent pieces here, I know that these two are equal, right? They're the same. So I can make an equation where they're equal. All right, so this is different than the segment addition partial because I don't know what the whole thing is. I just know that they're the same as each other. So we will solve this. All right, we'll take away 2x from both sides. We'll add 4 to both sides, and we get x is 5. So I can plug it into each one individually, and I'll make sure that I do get the same thing when I plug it in. That's how I'll know if I'm right or not. So 3 times 5 minus 4, 15 minus 4 is 11. And then 2 times 5 plus 1, 10 plus 1, oops, is 11. So we have 11 plus 11, AB is 22. right, so here's another one. M is the midpoint of segment VW. We want to find just VM this time, but the process remains the same. We know those are equal, congruent. So set the 4x minus 1 equal to the 3x plus 3 and solve. All right, take away 3x first. We'll add the 1. So x is 4. And now I'm putting it in just for VM. So just the 4x minus 1. So we get VM equals 15. So you're going to try these two. First, identify what's bisecting the segment, then find the specified length. Pause it, and then you can check your answers. All right, so for number 3, line L is the segment bisector. When I set my two segments equal, I get x is 2, and then I'm looking for MQ, so I'm going to put the 2 back into 11 minus 2x, and I get MQ is 7. For number 4, line N is the segment bisector. When I set my two segments equal, I get x is 7.5. And then we're looking for RS, which is the entire segment. So I put 7.5 in for both x's. Each segment's 33, so we have a total length of 66. Midpoint can also be done with ordered pairs. So if I'm looking for the middle point between two others, I want to know exactly in the middle of those points, which means I'm looking for the average. So if I have a point x sub 1, y sub 1, and another point x sub 2, y sub 2, I'm going to find the average of the two x values. So x sub 1 plus x sub 2 divided by 2. And I'm going to find the average of the y values, y sub 1 plus y sub 2 divided by 2. So for our first example here, the endpoints of segment RS are R and S. Find the coordinates of midpoint M. So we're going to use the formula we just saw on the previous page, x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. So we're going to take the two x's, 1 and 4, and that's going to be 1 plus 4 divided by 2. Then I'm going to take the two y's, -3 and 2. That's -3 plus 2 over 2. And now I just have to simplify. So we have 5 over 2 and -1 over 2. And that's it. I don't have to turn them into decimals if I don't want. I could just leave it like that. All right. If you wanted to turn them into decimals, that'd be 2.5 and -0.5. Right? Either answer is fine. We're going to look at example B a little differently. They're telling us the midpoint of JK is M. One of the endpoints is 1, 4. So the way I'm going to approach this problem is I'm going to put my points in order. We know J is 1, 4. We know the middle M is 2, 1. And then over here is K, but we don't know what it is. So since M has to be exactly in the middle, what I would do is I'm going to look, what does it take to get from 1 to 2, right? From the first x to the second x. And to do that, we went up by 1. So this middle point has to be the same number of units away from the new x. So that's another +1. So 2 plus 1 is 3. And then we're going to do the same thing for the y's. From 4 to 1, I went down by 3. So from the 1, I'm going to go down by 3, and I get -2. So I get a final answer for K of 3, -2. All right, you're going to try the last two. Pause it, and then you can check your answers. All right, check your answers here. We get a midpoint of -3/2, 4, or -1.5, 4. And for number 6, Q ends up being 0, -7. And that is day 1 of section 1.3.